Now that we've gotten a chance to go over the definition of a variable and have practiced with a few expressions, we're going to turn our attention to linear equations. Linear equations are going to be equations in which the variable is not raised to an exponent. For example, 3x plus 2 equals 12. On a test question, we're going to be asked to solve for the variable in a linear equation. There are steps in order to effectively isolate a variable. The first step is always going to be to eliminate any fraction. That's going to make the math easier. The next step is to move all of the variable terms to one side of the equation. Once you've done that, you can move on to step 3, which is combining like terms. Step 4, factor out the desired variable if necessary. And finally, step 5 is to divide by everything else, leaving the variable by itself. Now let's take a look at an example to practice those 5 steps. If 4x minus 7 equals 2x plus 5, what is x? Now our first step is to eliminate those fractions. But as you can see, there aren't any fractions in the equation. So we can skip step 1 and move on to step 2, which is getting all of the variables on one side of the equation. We can accomplish that by subtracting 2x from both sides of the equation. When we do that, we're left with 2x minus 7 on the left-hand side equals 5 on the right-hand side. Now we can move on to combine like terms. All of our x terms are combined and on one side, so let's combine the 7 and the 5. We can do that by adding 7 to both sides of the equation, leaving us with 2x is equal to 12. Step 4 is factor out the desired variable, but in this case we don't need to do that. We can move on to step 5, which is divide everything else out, leaving the x by itself. Divide both sides of the equation by 2, which leaves us with x equals 6. Now let's try solving an equation that does have fractions in it. The next example says x minus 2 over 3 plus x minus 4 over 10 is equal to x divided by 2. Step 1 is to eliminate all of the fractions. The reason that we start with this step is to make the math more accessible so that we're not finding a lot of common denominators and spending a lot of time doing calculation. In order to get rid of all 3 fractions at once, we're going to want to multiply both sides of the equation by a factor that allows us to cancel all of those denominators. What is the lowest common multiple between 3, 10, and 2? Lowest common multiple is going to be 30. So we're going to multiply both sides of the equations by 30. When you multiply the 30 by both of the terms on the left-hand side, we end up with 10 times the quantity x minus 2 plus 3 times the quantity of x minus 4. Multiply it to the right side as well, and we end up with 15x on the right side of the equal sign. Now let's go ahead and distribute the 10 and the 3 on the left-hand side. 10 times the quantity of x minus 2 equals 10x minus 20. 3 times the quantity of x minus 4 equals 3x minus 12. And then we have 15x still on the right-hand side. Our next step is going to be to get all of the variables on one side of the equal sign. In order to do that, we're going to subtract 10x and 3x from both sides of our equation, leaving us with negative 20 minus 12 equals 15x minus 10x minus 3x. Now we can move on to step 3, which is combining like terms. On the left-hand side, negative 20 minus 12 equals negative 32. And on the right-hand side, 15x minus 10x minus 3x equals 2x. Step 4 is to factor out a desired variable if necessary. Again, we don't need to do that in this equation. So let's move on to step 5, which is dividing everything else out, isolating our x value. Divide both sides by 2, which leaves us with negative 16 is equal to x. Now that we've practiced the 5 steps for isolating a variable with 2 examples, I'm going to give you a chance to try these steps on your own. Take a few moments to try the various exercises, and when you're finished, we'll check your answers and go through a few examples together. Okay, great work. Now check your answers. Okay, now that you've looked over the answers, let's start by going through number 1 together. In number 1, we're given an equation. 2x plus 5 is equal to 10. Let's walk through the 5 steps for isolating the variable and solving for x. Step 1, eliminate any fractions. Well, there aren't any fractions here, so we can move on to step 2. Step 2 is to put the variables on one side of the equation. Well, we can skip this step as well because all of the variables are on one side. Step 3, combine like terms. Now we can actually combine 5 and 10 by subtracting 5 from both sides of the equation, giving us 2x is equal to 5. Step 4, factor if necessary. Again, we don't need to do that. So we can move on to step 5, which is dividing both sides by 2, isolating x, and leaving us with x is equal to 5 over 2. Now let's take a look at example 7. Here we're given an equation 12 plus b over 3 is equal to b plus 10 over 6. We do need to eliminate fractions in this case. The fastest, most efficient way to do so is to cross multiply. Remember, when you have fractions on either side of the equal sign, cross multiplying will allow you to eliminate both fractions in one step. So in order to cross multiply, we're going to multiply the numerator of the first fraction by the denominator of the second fraction. So 6 times the quantity of 12 plus b. Put down your equal sign, and then the next step is to multiply the numerator of our second equation by the denominator of our first equation, or 3 times the quantity of b plus 10. Now that we've eliminated all the fractions, let's distribute before we move the variables around. Distributing the 6, we get 6 times 12 is 72, and 6 times b, which is 6b, leaving us with 72 plus 6b on the left-hand side. On the right-hand side of our equation, we have 3 times b, which is 3b, plus 3 times 10, 30. So our new expression reads 72 plus 6b is equal to 3b plus 30. Let's move on to step 2. Let's put all of the variables on one side of the equation. We'll do so by subtracting 3b from both sides of the equation, leaving us with 72 plus 3b is equal to 30. Now we can combine like terms. Go ahead and subtract 72 from both sides of our equation. We're left with 3b is equal to negative 42. Again, we don't need to factor, so we can skip the fourth step. Our last step is to divide in order to isolate our variable. Divide both sides of the equation by 3, leaving us with b is equal to negative 14. Now let's take a look at example number 9. We have the equation 4x minus 8 is equal to 12 times the quantity of 4 plus 3x. There aren't any fractions, so we don't need to worry about step 1. We do, however, need to distribute the 12 on the right-hand side of our equation before we can move our variables around. So let's multiply 12 times 4, that gets us 48, and then 12 times 3x, which gets us 36x. Our new expression now reads 4x minus 8 is equal to 48 plus 36x. Now we can combine our x terms. Do so by subtracting 4x from each side of the equation, which gives us negative 8 equals 48 plus 32x. Now we can move on to step 3, which is combining our like terms. We're going to subtract 48 from both sides of the equation, giving us negative 56 is equal to 32x. We don't need to factor, so we can skip step 4. So let's move on to step 5. Divide both sides of the equation by whatever we need to in order to isolate our variable. In this case, we're going to divide both sides of the equation by 32, leaving us with x is equal to negative 56 divided by 32, which reduces to negative 7 over 4. All right, now that you've gotten a chance to practice on a few examples, Let's try a test question. Number 11 says, if 5 minus 2x is equal to 15, then 5x equals. Note that the question doesn't ask us to solve for x. It asks us to solve for 5x. This means that we need to use our equation to get a value for x and then plug it into the expression 5x to find the answer. Don't fall into the trap on test day of choosing the answer choice that represents the value of x. Let's go ahead and work with our equation. 5 minus 2x is equal to 15. Our x terms are already on one side of the equation, so we can combine like terms. Subtract a 5 from both sides of the equation, which gives us negative 2x is equal to 10. Now move on to the last step. Divide both sides of the equation by negative 2, which gives us x is equal to negative 5. We're not done yet. We need to plug in that value for x into the expression 5x. So 5 times negative 5 is equal to negative 25, which matches up with answer choice A. Just remember that on test day, you are going to see a lot of linear equations. But if you practice the steps for isolating a variable and use order of operations, you will become very efficient at handling these equations.